Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Dianna. Hi, Fred.
Hey, Dianna. Hey, I heard you ran into a question the other day or a thought, and then you had actually went and saw an example of one of the extremes in this spectrum you heard about.
Yeah. Someone was asking me about what is the difference between reliability, testing for reliability for products where it's just a onesie-twosie or they're really expensive products versus products that are coming off of a production line in thousands. Like, how do you approach reliability for those different extremes? And then a friend got to, actually, I got to go on a tour. One of my friends works for NASA on the LEMS project, which is the Lunar Environment Monitoring Station. It's going to launch with one of the Artemis launches, and it's a device that is going to be installed by the astronauts on the lunar surface to be able to test for quakes and shakes. So it's going on the South Pole to do a little bit more environmental and stability testing of the lunar surface. I think to evaluate what could be built there in the future, maybe. So this is that one extreme where this LEMS project, there is one of them. They only need one. It needs to survive in extreme conditions. And they were just at the point of the project where, they're sort of wrapping up some testing and getting ready for launch. So I was not afraid to grill my friend who was nice enough to give me this tour in the evening. It's like 7 p.m.
Yeah.
And I'm getting the tour of their facility, which was really interesting. And so I just peppered her with all sorts of questions of what they're doing and how they're doing it. And it's different.
It's different than if you had 1,000 of them a day kind of thing. I always start with that reliability itself is not different if you have 1 or 1,000,000. Because as a customer, I don't buy 1,000,000 laptops, or phones or anything else. The one I have has to work.
Yeah.
Right. And the one on the moon, they have that customer is, the folks that are putting it there and reading the details coming out of it. It's the one that they have. They're the customer, and it just needs to work. So the probability of success over time might be different. I don't expect my phone to last 20 years and still be relevant and useful and functional. It might. I don't know how, I've had, Kirk has famously bragged about his iPhone 6, which I think he finally updated.
If my experience is anything like his, he'll walk into the store and they'll say, "Ooh, this is vintage."
Yeah. And so he's like, "Hey, if it still works, I can still get phone calls and texts and apps on it still work. And, it's got more and more security risks over time as the older software is not being updated and stuff like that. It's a form of aging, apparently, for these old technology on phones, for example. But if you're making 1,000,000 phones a month or a day, I don't know how many they make, sample size is amazingly still a problem. you don't get as many as you ever thought because they're expensive, relative. Yeah. If the only time I ever had more samples than I could deal with was I was testing different manufacturers' zip ties for cable holding, and you get a box of 1,000 or a jar of 1,000 of them. Do you need more? It's like $10.
Yeah.
And I couldn't use them all, but I think it starts with, what are you trying to do? What are the risks? What are the areas that you need information for? And whether it's 1 or 1,000,000, there's still risk. If you're going to launch a new product in a consumer market, say for a holiday season, you're making them in the summer and you're putting them in the boat or ships or whatever, and you're distributing it around the world. And then it's launch day. And now you got a million or more out there that either work or don't, because those first buyers are going to talk about how successful it is, how great it is, or how bad it is. And it'll make or break your sales for the next 6 months or a year.
Yeah, it really affects reputation.
Right.
Yeah.
So the risk is different. If this LEMS project doesn't work, it's going to be, we'll check it out and try the different stuff, and we'll put something on another launch at another day, and it's embarrassing, but it doesn't destroy your reputation, you know. Uh,
Well, it still could be linked to other projects down the line because this is information gathering
mhm.
for future decision making.
And if it delays it 5 or 10 years, you know, it's going to cost money. It's a thing, but there's nothing you can do about it. It's not like you're going to ship two of them up there and hope one of them works. If it was absolutely, totally, has to work, um, they'd put three or four of them out there.
Yeah, yeah. In this case, they're planning for that one,
Yeah.
and the kind of testing they were doing. I got to see some of their test chambers, and they're impressive, and they're used by different projects. They have to schedule time
Mm-hmm.
for the projects, and one takes priority over another one, and so they are testing not quite to the extreme that the environment is going to be. They're limited. They can get as close as they can to possible. But
Mm-hmm.
I asked, well, they're at the very end, like ready to go. I said, well, if it is in this environmental chamber with this reliability test and something fails, what do you do? And as well, we fix it, and then we might test it again or determine what other testing is needed.
Yeah.
So it was sort of like a halt test. Like they've already done halt testing, but now this is like we're getting ready to launch, and this is the sanity check testing, I suppose
Okay.
you would call it.
Yeah. But it's one where, I mean, there is a risk of any repairs you do, it was going to damage something else.
Yeah.
So that has to be built right into the design of how you put it all together. The constraints on it are probably weight. So it's not going to be in really high gravity, except all when it launches. It's got to survive that too.
Yeah.
And so it's,
And then with this device, it's going to be handled by astronauts. So they're
in
yeah.
really cool looking suits.
Yeah, they're going to have these big suits on with the big finger gloves or whatever, It's not easy to move around. So push, pull levers, that human interface, the usability studies were important. And they're even doing some of those studies in another lab where they have a simulated moon surface, so that somebody's going to don the full, an astronaut's going to don a full thing, and the actual astronaut that's going to be placing this device will be part of the simulation too.
Yeah.
So yeah, a lot of thought and effort into all the steps, launch. Yeah.
But it starts with, will it work in a soft soil environment? Even just functionalities. Will the sensors actually give us the information we're looking for if the
Yep.
soil is 6 inches of powdery dust versus 2 feet of powdery dust, or, whatever? Because where they're putting it, we've not been there before. So there's a lot of uncertainty. So a lot of the testing, I imagine, is, will it work? Can an astronaut with these gloves on actually turn it on, or
Yes.
position it and stuff like that? And then it's, well, what about, the solar radiation it's going to have, or what about the differential from the light side to the dark side of the device? Because that's going to be a dramatic temperature differential.
Yeah. And then, the dust getting in the way of the solar panels.
Mm-hmm.
How do you account for that? And
Oh,
then,
you just have to fly up every couple of weeks with a hose and wash it off.
yeah, like we do here.
Yeah.
Yeah. Yeah. So yeah, a lot of really interesting variables. It's an interesting project. I'm looking forward to following it.
Well, it's one of those where, and it's not that different than the way they tested tanks in the 60s, 70s. They take one or two tank prototypes they've mocked up and run it through a test track, and something falls off or breaks or disconnects or whatever. They fix it and keep running the test, and it's a growth pattern. And so the idea is that will it make a 20, a 1 week mission? Will it survive with proper fuel and maintenance? And they would set a criteria like that, and they'd run this thing around this track and simulate this, that, and the other thing of use, and then fix things as they go and make improvements. And hopefully it was good enough by the time they run out of money and time. And I was just reading about the invention of the Klystron, I think it's pronounced, back in the late 50s by Varian. And it was one they built and sold it. And they said, oh, maybe we should make another one, and created a business out of it and made hundreds and hundreds of them. But it was very low volume.
What did it do? I don't know this product.
It got used in satellite or missile detection during the Cold War. It got used in, it was like 30 megawatts. It's a device that takes power and ramps it up to huge amounts of wattage. And so it was used in like radar type systems. It was used in medical devices. I've seen it being used in those for like radiation therapy type stuff. It's like 20 feet away from me where the article is, but it was a short blurb about how they got started in a handful of places that got used. And it's like nothing I've ever used. I think part of it was even used in microwaves. A smaller version of these things eventually became a microwave device. And I'm not sure if they still use that technology or not, but it was physics on steroids kind of thing. Is the way I interpreted it.
Okay. I'm going to look this up.
Yeah, it's used in Slack for particle acceleration. It's one of the tools that's used to get enough power into the linear accelerator at the right places and timing and stuff. So there's a handful of applications for it. But the idea is that, yeah, some products are very, very low volume, and that's okay. And that's the market. That's the use of it. They're expensive. You don't get a whole lot of them. Yet you have to take into account that if you fix something, hopefully you don't break something else. And making a replacement's not good enough because it broke. And now you know about this failure mechanism, and you don't want that to happen in real life. And I imagine this LEMS device is not going to be there or expected to last the 6 months or something. It probably needs to last years.
Yeah, I think so.
And
that was the one question I didn't ask her.
But it's one of those, the longer it lasts, the more information they get, the more useful it'll be. And the idea of a single unit and no prototypes is risky. Yet, given constraints and budget and all the other things we do, that's what it takes to make it happen. That's what's going to, but it's a lot of energies thinking through, well, what about lower gravity? What about solar radiation? What about a dust storm, whatever that might be? Because this lunar lander is going to have to take off, and there's going to be a bit of dust kicked up, I imagine.
Yeah. Mm-hmm. Well, but on the other hand, with the parts that are made in the thousands, like you mentioned, the zip ties, with those, and you mentioned, they're distributed to people, and there's reputation on the line that could affect, the business profitability. Within those, also, you're dealing with, you want it to be consistent, but you're dealing with the variability that's introduced in just mass production and mass manufacturing. Right. So that's a different angle that you need to look at when you're looking at the mass-produced products like that.
That's right. It's a different threat. Instead of moon dust, now we have manufacturing and vendor variability.
Yeah.
And will the original when I first was working as a manufacturing engineer in a factory, it was obvious to me all of the problems we had on the shop floor was because of the design. it was it wasn't it didn't have any software associated with it, so it was obviously the design's fault. And one designer took offense at that and said, what do you mean? He says, well, if you would design it such that we could put all the components in a paper bag and shake it up and it would assemble itself perfectly, then it would be a good design. And he didn't care for that sentiment at all.
he, he he didn't take the bait, huh?
No, no. But the idea is that in it's just a different constraint, whether it's the environment or the stresses it's going to see, which we may or may not know characterize completely with a new product in a new environment. But if you're making cell phones for the last 10 years, you pretty much got the how people use it and how often and what environments and so on down. And we still make mistakes. I think it was a year or two ago, a new iPhone came out and it didn't like being in the cold. So people would get off the bus in New York City and walk down the street and their phone would stop working. And it was because it just got too cold.
Yeah, I saw something about that with one of the electric cars in a
Yeah.
really cold environment. Somebody put a heater near it to keep the
Mm-hmm.
batteries warm so we'd have a car in the morning. And
That's right.
you can imagine, yeah, what happened. Explosions and
Oh,
nobody got
yeah.
hurt, but
Well, it's not like combustion engines have a market on that. When I was in Wisconsin, we used to put a block heater. You could attach it to the block, and it was a little strip heater that you'd plug in. But you could just put a 60-watt light bulb under the hood, and that would be enough heat to
yeah.
keep the oil from being so sluggy that it would not allow you to turn the engine over. Yeah, building a fire underneath it is the last resort, but it can be done. But in the volume stuff, there's the constraints are usually a very tight budget, a very tight timeline. You might know the environment, you might know the risks that you're going after, except for that new assembly step that nobody told you about. That is a blind connector type thing in the back of the device. I've seen that before. And it's a combination of design and manufacturing have to work really closely together to minimize the variability, which is completely different if you're only making one. It's just a difference, in my mind, it's a difference in constraints that you have
Yeah. Hmm.
and unknowns. But you both of them have to start with it needs to work. And what would prevent it from doing that? So risk assessment tools like FMEA and HALT help us identify what are those areas of concern are. And it's funny. I don't want to use it as a guide, but when you get a product back and it comes back after 2 weeks in the field for a volume product, the default is it's a manufacturing error and we send it to manufacturing to fix.
Yeah. Uh-huh.
Right. And if it lasts 5 years and it fails, then it's a design issue. You send it back to design to learn from it. And I'm like, no. They're all design problems. This is my manufacturing engineer bias coming in. If it was manufacturable by design, we wouldn't have those problems. Now, there's still risks if a vendor changes something or some part of the manufacturing process gets out of control and stuff like that. Yes, it does happen, but it's in better designs with the manufacturing process, it's seriously minimized. If you're only making one, it's a craftsmanship. You have
Yeah.
to have craft people that really know their trade to build the one very, very well and take pride in that, which is not done when you're doing a million of them. You're sitting shoulder to shoulder, or there's robots doing a lot of the assembly systems. It's
Or the machines with all the different controls and settings and yeah.
right.
Hmm.
It's there's still craft there, but it's hard for an operator of a piece of equipment on the assembly line to say, yeah, I built this, because they had one small step in it, kind of thing. So it's a different set of constraints. The tools, FMEAs work in both systems. Accelerated life testing works in both systems. Environmental testing works the same in both systems. Types of approach. Almost every single tool that we use applies. I think process capability and control charts probably are not so useful for a one-off device.
Yeah, no. That's true. Yeah, I was trying to think the quality measures. There would still be quality standards and measures that you would do, but like you said, it's more if you're making one, it's more of a craftsman expert type of quality managed. You would really have to just manage the system,
Right.
the interactions of things. But yeah, I agree. As I was getting that tour and she was talking about the different tests they were running or what they've done before and answering all my questions, which I do appreciate, Diane. Thanks. But I was thinking, a lot of the same tools that I used in, catheter manufacturing, for example, would have been the same. It's the same idea, but like you said, it's different constraints, different targets, and depending on its use, a different problem.
Well, I think one of the benefits of this really low volume is that you're not going to get 1,000 samples. If you're making 1 million units, you can ask for 1,000 samples. You're still not going to get 1,000 samples.
Yeah, right.
Very, very rarely. I think the constraints still exist. In one place, it up front because you're only making one.
Yeah, and you can plan for it.
Yeah, yep. But all the other tools apply. It's being a different set of boundary conditions, I think, is the real difference between them. But the approach to reliability is, what are you trying to achieve? What are the risks? What do we need to know? And then let's go to the lab and sort it out. But it's other than that, it's still a risk, right? We're going to ship one or we're going to ship 1 million, and we keep our fingers crossed at the end of the day that it works. It's not to call our business wishful thinking, but we'll never know everything. And we just need to reduce the areas that are of the highest concern, highest risk.
Yeah. So, it's still all just, I don't know. It's fun, isn't it? Whether you're making a onesie or if you're making thousands.
Yep.
It's just a reliability, and I also do quality also. But it's just all fun no matter what it is you're making, and it applies to all situations, and there's just things you can do to help people make better decisions.
Yes. Well said. It is about helping folks make better decisions, and a lot of our work is focused on that. And I'd say all of our work is focused on that.
Yeah.
But good question that came up, so whether you're listening to this and looking at, the 2 units that you're ever going to make with no prototypes, or 2 million that you're going to make this week and hope they work for the holiday season, or somewhere in between, what are the sets of constraints or set of tools that you have to apply differently, or what differences did we miss in this short discussion of it? We'd love to hear from you on it. Or if you have other questions related to reliability, quality, and safety, risk, all those associated fields, makes great starting points for discussions on the show. You can do that over at accendoreliability.com/go/SOR. There's a couple of ways to get in touch with us. Dianna and I and the other hosts of the show are available through LinkedIn and our About pages. So there's plenty of ways for you to join the conversation. And unfortunately, over the last couple of weeks, it's been a very low volume of questions coming in. So none.
Everybody's head down working, getting stuff done.
Well, tough. You got questions. Come on. We can help you. We get you an answer back as soon as we can, or at least a direction or an idea. And then we'll go talk about it and really learn what the answer is, and then feed that back to you too. Hopefully it's still useful for you.
Yeah. Yeah. And thanks to Roger for the prompt on this one.
All right. Thanks, Roger. And well, thanks so much for bringing it up, Dianna. Good topic.
Yeah. Thanks for chatting about it.
All right. Talk to you soon.
Okay. Bye.
Bye. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.